Hello again everyone, welcome back to ptet.chemistry channel. So this is a continuation of the further balancing chemical equations that I did that I'm currently teaching for the current year 9. Year 9 is 14 to 16 years old curriculum for the IGCSE or O-level or whatever other curriculum that you're doing. This kind of balancing equation is a skill set that is typically learned at a fairly early stage of these 14 to 16 years old chemistry curriculum. Okay. So in this further balancing equation work, I'll continue on the last 20 questions. It was a 40 question series, and I did cover the rest already in the other lecture tutorial, so you can have a look at it. And hopefully in that lecture tutorials you have found out that what was accepted and what was not accepted, and you can hopefully go through these video tutorials, pause it and try it yourself first before you watch me do it, and then you can check your answer and see whether you get them balanced or not. Alright, so that's the whole idea about learning. Now in this first question, so we have this scary looking formula. I always start with the scarier one because the more atoms it have, usually we want to try and simplify it first. We want to work with the simplest number so that our balance equation doesn't get out of hand and involve big and bigger number that become much harder to balance. So if I have one of these, that's my assumption. If I start from that, I have one of the 1 times 2, which is 2 iron, so I will need 2 iron. And if I put one of these and I have 3 unit of SO4, I mentioned that it should be SO4 2 minus, but when we are balancing equation, we are thinking of it as 3 SO4. There's only one of the SO4 here, so I need 3 of the H2SO4 to try and balance this thing very easily. Now the iron and the sulfates unit are balanced. Now in terms of the hydrogen, so there is 3 times 2, which is 6 H atoms, 6 hydrogen atoms. There is 2 hydrogen atoms there already. I cannot change the number at the bottom, so what I do is 3 H2 molecule, which will mean 3 times 2, 6 hydrogen atoms. The next thing is what I mentioned as combustion. Combustion because you're combusting or burning this organic compound in an oxygen to give you CO2 and water. You will learn more about this in organic chemistry. The idea here is you have one of these and you have 2 carbon atoms. All the carbon atoms go to carbon dioxide, so you always do it in such order. You assume there's 1, and then you have 2 carbon, 2 CO2, and then you look at the hydrogen. There's 1 times 6, which is 6 hydrogen. This is H2O. To get to 6 hydrogen atoms, you need 3 of it. 3 oxygen atoms plus 2 times 2, which is 4 oxygen atoms. We need 7 oxygen atoms, and it so happened that this is all 2 molecule. Something times 2 will give me 7. So something times 2 will give me 7. That's something equal to 7 over 2. So 7 over 2 is a scary looking thing for a lot of O-level students or IGCSE students, partly because the teachers always tell the student not to put fractions down. They didn't say it was wrong, they just say it's discouraged, but then by right it's just a symbolic representation, because what happens at molecular level, even our eye cannot see, even microscope cannot see. This is merely a symbolic representation, and if you have gotten the simplest ratio right, it will have been okay as well. If you really don't like fractions, you can multiply the whole thing by 2 to get rid of the number at the bottom. If you multiply by 2 throughout, 1 times 2 will be 2, 7 over 2 times 2 will be 7. What you do has to be done throughout and not just for what you want to do it, because otherwise it will not be balanced anymore. So 3 times 2 is 6, 2 times 2 is 4. What I'm saying is you could do this whole number thing, or you could do this and it will still be exactly balanced, because I've not changed the identity of the molecule or whatsoever. Alright, so the next thing is between a base. This is a base, or what we call an alkali, whatever you want to pronounce it. This is phosphoric acid. Acid and base give you salt and water. This is a classic neutralization reaction. Anyway, this question is not asking on neutralization, it's asking you to balance equation. So I could see the K3, meaning there are 3 potassium here. So if I say there's 1 of it, then I have 3 potassium on the right hand side that I must get from 3 KOH, because I must have 3 potassium. And there's only 1 potassium here. I can't change the formula itself, I can only change the number in front. So after that, I have one of the phosphate unit, 1 time PO4. There is 1 time PO4 here, so I just stick with 1. And then now I look at my hydrogen. So 3 hydrogen, 3 times 1 is 3 hydrogen. 1 times 3 is 3 hydrogen. Altogether, I have 6 hydrogen atoms on the left. I need 6 hydrogen atoms on the right. I have a H2, 2 hydrogen atoms, so I just need 3 H2 or molecule. 3 times 2 is 6 hydrogen atoms. Now, I don't need to worry about the oxygen from the phosphate because as long as 1 PO4 gives you 1 PO4, the oxygen from there are balanced out. I just need to worry about the oxygen from here. 3 times 1 is 3 oxygen. 3 times 1 is 3 oxygen, so that thing is balanced on its own. Sn is tin, so this is Sn4 plus and this is O2 minus. A lot of students look at it and they thought there is Sn2 plus. When you name it, you will name it as tin 4 oxide. So be careful about name, be careful about the identity of the ions present, and be careful about where the chemical formula come from exactly. So what we're doing here is, let's say I start from 1 SnO2, 1 of the tin, 1 times 1 is 1 tin, will give me 1 tin, and then 2 oxygen here, 1 times 2 is 2 oxygen, so this will give me 2 H2O because 1 oxygen there, 1 times 2 is 2 oxygen. Let's have a look at the hydrogen. 2 times 2 is 4 hydrogen atoms. Total on the right hand side is 4 hydrogen atoms. I need 4 hydrogen atoms, so I need 2 H2 molecule because 2 times 2 is 4 hydrogen atoms. Next one, what do we have here? If I start off with 1 NH3, so we always start off from assumption, simplest number, okay? Not always true, but it's okay to start small. If 1 NH3, 1 nitrogen will give me 1 nitrogen here. So because there's no other nitrogen species, so 1 nitrogen give me 1 nitrogen because there's nothing else that contain nitrogen. So 3 hydrogen from there. So this is H2O. I need 3 hydrogen atoms total. So I have 3 over 2 because 3 over 2 times 2 is 3. So this is starting to look complicated because this is H2O molecule, right? But not a big deal. Let me just continue with this just to prove to you that it can be done. And in terms of the oxygen, how many atoms do we need? I'm talking about atoms. If we count the right hand side, 1 times 1 is 1 oxygen atom. 3 over 2 times 1 is 3 over 2. So 3 over 2 plus 1, meaning 3 over 2 plus 2 over 2, you get 5 over 2. So you will get 5 oxygen atoms altogether. Nope, that is wrong, that is wrong, that is wrong. You have 5 over 2 oxygen atoms, so be careful. So what you actually need is, you need molecule. So something times 2 will give you 5 over 2. Something must be 5 over 4. This is a scary looking thing now because you're not just looking at 2, you're looking at 4. And I'll tell you why this is correct as well. Because if you multiply by 4 throughout, so all this while I'm just working in the simplest ratio possible. I've been very careful about what is atoms and what is molecule, because atoms, molecules, ions, elements, compounds, mixtures, they are all in the fundamental, most basic thing of your syllabus. 1 times 4 is 4, 5 over 4 times 4 is 5, and 1 times 4 is 4, and 3 over 2 times 4, 3 over 2 times 4 is actually going to be 6. And you could do the whole number thing and it will still be balanced exactly. And I get these by getting it from these fractional values that I multiply throughout. And if that is correct and balanced, this thing must be correct and balanced as well. Okay. So there's nothing wrong with balancing question with fractions unless the question specifically asks for whole number, or in sometimes multiple choice question they ask you to compare certain mole ratios where they say this is 5, then you cannot leave it as fractions, you have to leave it in terms of where this is 5, for example. Okay. Moving on to the next question. So what we have is, I can see there's K2CO3. If I start with one of these, then I can see I need 2 potassium. I only have 1 potassium here, so I need 2 potassium. So 2 of these would mean I need 2 times nitrate is actually NO3 minus, but for the sake of balancing equation, we're just looking at 2 times NO3. This is 1 time NO3 in 1 nitric acid unit, so I need 2 of that to give me 2 of the NO3 now, because one of it only got 1 NO3, 2 of them will have 2 NO3 to balance the NO3. This has got one CO3, not CO2. So here, I only need one CO3, so I just have one there. Let's have a look at the hydrogen. So 2 hydrogen atoms, 2 times 1 is 2 hydrogen atoms, 2 potassium, 2 potassium, 1 CO3, 1 CO3, 2 NO3, 2 NO3. I have mentioned CO3 and NO3, but they are ions actually. CO3 2 minus, CO3 2 minus, NO3 minus, NO3 minus, just to remind you that I did not mean to add molecules, okay? Be very careful. Next one, this is B2Br6. So this is the bigger looking molecule. So I'll just assume I have one of these. Then I have 2 boron. Boron is element number 5 in the periodic table. 2 boron. So I need 2 of the boron because there's 1 there. 2 times 1 is 2 boron. There's 6 times 1 bromine. So there's 6 bromine altogether. So I need 6 bromine. So 6 HBr to give me 6 bromine. I have 3 of the NO. Hang on. In one of these, I have 3 of the NO3 unit, but I've got 2 of it as a result of these. So altogether, I have 2 times 3, which is total of 6 times NO3. So if I need 6 times NO3 and I only have 1 of it here, I need 6 in front there. Let's have a look at the hydrogen. 6 hydrogen, give me 6 hydrogen. Everything else is balanced as such. Next one, so again, this is 1 there because I can see this is the bigger looking substance. So B2, there's 2 boron, so 2 times 1 is 2 boron, so 2 BF3. 2 times 3 is 6 fluorine, so 6 fluorine altogether, so I need 6 LiF. I can see that I have 3 of the SO3 and there's 1 in front, so there's just 3 SO3. It's actually SO3 2 minus. This is sulfite, by the way. This is not sulfate. This is ITE. Told you the table before, a couple of lecture tutorials ago. You gotta be aware of this kind of thing. The sulfite is SO3 2 minus ion. The sulfate is SO4 2 minus ion. I need 3 sulfite. I only have 1 SO3 unit here, so I need 3 in front. 3 times 2 is 6 lithium. 6 times 1 is 6 lithium. This equation is balanced. Nope, that's not a good color. Let's have a look at the next one. It's looking more complicated now. So you can see I've got ammonium phosphate. So the name of this thing, you should be able to name it if you know your ions. Of course, if you don't know your ion, it's time to go back to a couple of lecture tutorials ago and go through the common formula of ions and their names, as well as how I get to the names or get to the formula from the other way around, okay? So if I have 1 of these, let's start with this assumption. So I've got 3 of the ammonium unit. I have got 1 of the ammonium unit here. Ammonium is actually NH4 plus. For the sake of balance equation, we'll just look at NH4 as such. 3 of the NH4, 3 times 1. So I need 3 of these. By doing so, not only I have 3 NH4, I also have 3 NO3 now. So total, I have 3 times NO3. So this thing you don't really have to write down. These things are what you think in your head. But if you are a beginner, you should really see this kind of thing by writing them down so that you can see what's going on. But once you get to a stage where you are comfortable without writing them down, so these are things you do in your head as you become more and more accomplished chemistry student. Okay, so total of 3 NO3. So here we have a dilemma, isn't it? We have a big issue because here we already have 4 times NO3. So we have 3 times NO3 and 4 times NO3 here. What can we do? Let's see. That might not be the best way to start then, I guess. Perhaps I shouldn't start with 1 of these. Perhaps I should start with these instead. So let me just cross that out and let me start again. So I'm not saying that, every single time you always, let me start with 1 of these. Then I will have 3 of the PB. So I need 3 times 1 of the PB. And then I will need 1 times 4 equal to 4 of the PO4. So yeah, I think this will look better. I need 4 of the PO4. I need 4 of the PO4. I will need 4 times 3, which is 12 of the NH4. We need 12 of the NH4, which is the NH4 plus actually, so 12 of it. And I'll get 12 nitrate, 12 of the NO3 unit. And in doing so, you can hopefully see that you get 4 of the NO3 times 3, you get 12 of the NO3, and this equation is balanced nice and happily there. Okay, on to the next one, SeCl6. If I start with one of these, one selenium is group 6 element, just below oxygen and sulfur is Se, and they will give you one selenium, and 6 Cl, 1 times 6 is 6 Cl, that give you 6 chlorine atoms, so that is 3 times 2, give you 6 chlorine atoms, 2 oxygen atom remaining, so 1 oxygen molecule, 1 times 2 give you 2 oxygen atoms, 1 times 2 give you 2 oxygen atoms. So moving on, these are the last 10 questions of this part 2 of these further balancing questions, and hopefully so far you have picked up most of the required skills, and hopefully you'll be more confident going forward. Without further ado, let's get started with this question 1. So here we have another combustion reaction. So I've talked about combustion in a couple of examples previously. So where we burn an organic compound in excess oxygen and we get carbon dioxide and water. And if we start out with one of these organic molecule, organic meaning to say, well, things that contain carbon are organic, and you will learn more about this in organic chemistry at a later stage. So 1 carbon will give you 1 carbon there, and that means 1 carbon dioxide, because 1 times 1 is 1 carbon atoms. 1 times 4 is 4 hydrogen atoms. You need 4 hydrogen atoms, so you need 2 H2O molecules. 2 times 2 is 4 hydrogen atoms. Now you got to add up or sum up the total number of oxygen atoms. 1 times 2 is 2, 2 times 1 is 2, altogether 2 plus 2 is 4 oxygen atoms. You need 4 oxygen atoms, whereas you have an oxygen molecule and you can't change that fact, so 2 times the oxygen molecule will mean 2 times 2, which is 4 oxygen atoms. On to the next one. This is a strange looking one. This is actually a +1 and a -1. That is because the ion, the cation and the anion, they combine together to give you this ionic compound. Ionic compound has no overall charge, and this ionic compound consists of 1 Na plus and 1 Cl minus. So I know 1 and 1 of these give you 1 of these ionic compound. The overall ionic compound has no charge, but ionic compound contain ions that are charged. The structure of ionic compound is a giant ionic structure, and those are all covered, well, in fact those were all covered in the structure and bonding topic well, about a month or 2 ago, so you can browse back to those lecture tutorials and recap and refresh your concept so that you never forget this kind of basic simple stuff. On to the next one. If we have this thing called aluminium oxide, as you know, Al3 plus and O2 minus. In case you forget, +3 -2. When we do the cross multiply thing, we never cross multiply the ions, we never cross multiply the charges, we cross multiply and bring down the value, the number. The number on -2 is 2, the number on +3 is 3. What does this mean? This number represents how many of these ion you need, and that's why we never cross multiply the ions or the charges. 2 on the Al3 plus mean Al3 plus and Al3 plus, O2 minus, O2 minus, O2 minus. So altogether we need Al3 plus 2 of them and O2 minus 3 of them, such that the charges cancel out. 3 plus times 2 is +6, -2 times 3 is -6, +6 -6, the overall charge of an ionic compound is 0. If I start out with one of these, then I have 2 aluminium. 2 aluminium would mean 2 aluminium there. 3 times 1 is 3 oxygen atoms. So we need 3 oxygen atoms. As I mentioned a couple of times already in the last lecture tutorials or earlier in these tutorials, this is a molecule. We only need 3 oxygen atoms, so it has to be 3/2. Because 3/2 times 2, if you can see these mathematics, hopefully you can see this will give you 3 oxygen atoms here on the right hand side, on the left hand side. So what we have then, however, is we can multiply the whole thing by 2, because it's just a symbolic representation. You could have put down 4, you could put down 3, you could put down 2, and that will give you 2 times 2, which is 4 aluminium. 2 times 3, which is 6 oxygen. It's the same as 3 times 2, because 3 of these molecules will mean 6 oxygen atoms as well. On to the next one. There's a slight mistake with this question. There cannot be N2 plus, it has to be molecule. This is part of a very famous reaction. In fact, it's a case study in O level or IGCSE level. It's called Haber process, whatever you want to call it. It's basically the synthesis, the production of ammonia from reacting nitrogen and hydrogen. If you have one of these, then you have half of N2 and you will need 3/2 of H2. This equation is balanced the way it is, but a lot of times this is a case study, so what they do in fact is they just give you the whole number. So 2NH3, so 2 nitrogen atoms would mean 1 of the nitrogen molecule. 1 times 2 is 2 nitrogen atoms. 3 times 2 is 6 hydrogen atoms. To get 6 hydrogen atoms, you put a 3 there, so that 3 times 2 is 6 hydrogen atoms. Question 5, we have, well, let's start off from this thing on the right hand side. You have C8H18, pretty big looking molecule. I assume I have one of these. Then 8 carbon comes from 8 CO, that has got 8 carbon. 18 hydrogen comes from H2, 18 hydrogen, so I need 9 H2 there. 9 times 2 is 18. Actually that is wrong because I forgot to account that the fact that I also have hydrogen there, so that is no good at all. I guess the next thing I shouldn't go for the hydrogen, should go for the oxygen first. 8 times CO will mean 8 oxygen because 8 times 1 is 8. There's no oxygen here, no oxygen there, so all the oxygen here come from here. 8 oxygen there because 8 times 1 oxygen. That means I might have 8 H2O because 1 times 8 is 8 oxygen. Now I have total up the hydrogen, which is 1 times 18 is 18, plus 8 times 2, which is 16. Remember, this is number of hydrogen atoms because we were talking about atoms here. So this is a molecule, so be very careful what we are doing here. This is hydrogen atoms. And to get 34 altogether, 2 times something will give you 34. There must be 17 and not 34 here. I hope you can do that on your calculator fairly easily. The next one, this is a strange looking one actually. But since the fact that they're already given us, I don't like this at all because this would mean it's iron 6, and I have never heard of iron 6 oxide before. Anyway, let's assume that I don't know about the chemistry. I'm just trying to balance the equation. So let's just balance the equation since they're already given us the formula as such. Let me try and see if I can balance it in the first place, alright? So this is iron plus 6, and that is not something that is very commonly seen at all. I changed my mind. I think I better change this to Fe2 or 3, then that will make more sense. If I have one of these, then I will get, so this is what you call iron 3 oxide, by the way. So it's iron 3 plus and O2 minus, okay? So that will give you 2 iron because 2 times 1 is 2. And this is actually, yes, it must be Fe2O3. This is your extraction of iron. It's a case study in under metals, especially on the extraction of iron, which is historically very important. In fact, it's still very important. You get stainless steel by starting from iron first, and then you mix something to the iron to give you stainless steel, which is very, very important technology in a lot of stuff. Yeah. How do I balance this equation? I've got 3 oxygen plus how many will give me this? This is a bit tough to balance. Let's see, if I put 3 oxygen there, 3 oxygen, if I have 1 here, then it must be 1 because number of carbon is number of carbon. The oxygen doesn't work out. If I have 2 here, then what happened is the carbon is balanced, but the oxygen, 2 oxygen plus 3 oxygen is 5 oxygen. I have 4 oxygen, so that is not balanced. If I have 3 then, 3 oxygen plus 3 oxygen is 6 oxygen. 3 times 2 is 6 oxygen. 3 carbon, 3 times 1 is 3 carbon. There's 1 carbon there. 3 times 1 is 3 carbon, so carbon is balanced. 2 times 1 iron, 2 iron, so this equation is balanced now. Okay. Question 7, so this is sulfuric acid and this is hydroxide. Anything that contains hydroxide is going to be a base, and sulfuric acid is an acid. So this is your classic neutralization, or what we say acid-base neutralization reaction to give you a salt and water. There's 4 hydroxide. If I just look at this, one of these will give you 4 hydroxide. There's 2 sulfate unit there, 2 of the SO4 2 minus, should be SO4 2 minus. For the sake of balancing equation, we just look at the atoms. 2 of that SO4 unit, I only have 1 of the SO4 unit in 1 sulfuric acid, so I need 2 of that. So 2 times 2 is 4H, 4H there, and 4OH. 4 of the H plus, 4 of the OH minus will give you 2 of the H2O, because 2 times 2 is 4H, 2 times 1 is 2 oxygen, and nope, that isn't right. It should be 4H2O because it's actually 4 of the H and then another 4 of the H give you 8 of the H, and 4 of the oxygen, 4 of the oxygen, like that. Alright, and don't forget I should put a 1 there to signify that there's only 1 to begin with, because 1 times 2 give you 2 sulfate units. The next one is a metal acid reaction, give you salt and hydrogen gas. So if I have 1 of these, then I've got 1 aluminium, and I've got 3 chlorine, so 3 HCl. I've got 3 hydrogen atoms. We need 3 hydrogen atoms, not molecule. This is a molecule. Something times 2 give me 3. It has to be 3 over 2. As I mentioned a couple of times before, again and again, this is entirely correct. It's balanced, except that it's using fraction. If you really don't like it because of the fraction 2 at the bottom, 3 over 2 times 2 is 3, so that's balanced. If you don't like the fraction there, you have to multiply the whole thing by 2 to get rid of the 2 at the bottom. So it's up to you whether you leave your equation like that, depending on what the question is asking for, or you can balance it by using whole number ratio. So I've just multiplied the whole thing by 2, so each of the number will be multiplied by 2, and that will become 3 instead of 3 over 2, and you will see the equations are exactly balanced as well. The next one, this is a calcium phosphate, so you have PO4 3 minus, you have calcium 2 plus, and that's how you get this formula. Should be able to get these as well as the name by knowing that the ions has such and such formula. So this is just exchange of ions. This is a salt and an acid. The sulfur has just gone to the calcium and it's gone. In fact, the calcium has gone to 2 different places. This is now calcium with scary looking thing. It's not easy to balance this one. I think I'll come back to this. I'll finish off this one first. H3PO4 and HCl. Let me just finish off this one first. This is not easy to balance as well. I guess if I have 1 of these, I have 5 Cl, so I have 5 HCl. What's the next one? If I have 1 for P, if I have 1 of the P, that means 1 P will come from 1 P as well. So 1 phosphorus, 1 times 1 phosphorus give you 1 phosphorus, give you 1 phosphorus. Let's think about the hydrogen. So 1 times 3 is 3 hydrogen, 5 times 1 is 5 hydrogen, 5 plus 3 is 8 hydrogen. I need 8 hydrogen from that water, so I have 4 H2O. 4 times 2 is 8 hydrogen. I've got 4 oxygen. 1 times 4 is 4 oxygen, so this equation is balanced. Now I've got to worry about this thing now. The sulfate, I guess, is the easier one to balance. So with this kind of thing, it comes down to decision. Yeah, there's no sulfate here. There's no sulfate here. There's a sulfate and sulfate here. There's only 1 times sulfate. This is okay. Let me start with 1 of these. Then I have 1 of these. If I have 1 of these as well, that means 1 of that will be 3 calcium and 2 of the phosphate. Okay, 2 times of the PO4. Then this must be 2 of these, but that will be wrong, isn't it? That will be wrong because even though the calcium is balanced, 1 calcium plus 2 calcium is 3 calcium, but the phosphate unit, yes, this is not exactly PO4 3 minus, but you can think of PO4 unit. You have 2 of them, then 2 times 2 is 4 of them, whereas you only have 2 of them. So what I can do is that there are 2 phosphate here, so it must follow. So if I have 1 of these here, I must have 1 of these there. Means I started out the wrong way. Therefore I already have 2 of the 4 P of 4 unit, comes from 2 of the P of 4 unit. If I have 1 of these, I must have 1 of these. If I have 1 calcium here and I have 1 of this whole thing, so this give me 1 calcium, this give me 3 calcium, therefore it must be 2 calcium here. And because of the 2 there, you have 2 of the sulfate, and because of the 2 of the sulfate, I must have 2 of the sulfuric acid. Let's see if the equation is balanced now. 3 calcium, so 2 calcium plus 1 calcium is 3 calcium. 1 of the PO4, well, with 2 of them, so 2 of PO4 units. 2 of the PO4 units, but don't forget you get H2 and 2 of them, so you get 4 extra hydrogen. 4 extra hydrogen. 2 times 2, 4 hydrogen there comes from, well, give you that 4 hydrogen there. 2 of the SO4, 2 of the SO4, the calcium is balanced out. So the order of doing things matter, whether your life will be easier or difficult. So think about that and learn from what I've done. Okay, so that's it for the second part of further balancing chemical equations. A lot of it come down to extra practice, and which is why I've given you a little bit more work on these kind of exercises where a lot of students, a lot of you still couldn't quite balance out the way you're supposed to very quickly and correctly on a consistent basis. Okay, thank you for watching. Follow me at ptet.chemistry on Instagram, Facebook and Twitter, and browse around for the other lecture tutorials as well as previous topics which you have struggled with. And yeah, click the button on the bottom right to subscribe to the channel, and see you in the next tutorial video. Thank you for watching.